Okay, so I want to do a couple problems to help people understand some of the improper integral questions that occurred. The first one I want to do is number 12. And number 12 you have to do by partial fractions. You have to break it up into a over x plus b over x minus 1, or you could switch them. So you work it out that x is equal, or b is equal to 3, and a is equal to negative 3. Okay? So this is what you're going to actually go back and integrate. As b goes to infinity, so that works out, that is, both these are natural logs, so this is negative 3 ln of x, absolute value. This is 3 natural log of the absolute value of x minus 1, and we're going to look at it from 2 to b. Okay? But I want you to note that these both have the same coefficient, so we're using our rule of logs, we're going to get 3 ln of x minus 1 over x. You really need to combine these together. Okay? Now we're going to go substitute in b and 2. Well, as you plug in b, I get b minus 1 over b. As b gets really large, this becomes a ratio of 1. Okay? And then what is the natural log of 1 is 0. That's a fact we've got to make sure we remember. Okay? The other one is I get negative 3 ln of 1/2. All right, that's not the answer in the book. I want to show you how to get to that. So negative 3 ln of 1/2, I'm going to rewrite it using my rule of logs again, is negative 3 ln of 1 minus negative 3 ln of 2, which natural log of 1 again goes to 0, and this I just get 3 ln of 2. Okay? So at least you wanted you to see that one. The next one I want to do is number 28. Number 12 I think is reasonable. 28 is getting out there. It's not the integration is difficult. It just takes us a while to get there. I shouldn't say a while to get there. It's a straight substitution question. But I wanted to make sure I did it for you. Okay. So we're going to let u equal to the x to the, negative square root of x. So du is therefore negative 1/2 x to the negative 1/2, which is really negative 1 over 2 root x dx. Okay, so if you look at this, this is e to the u. Well, this is very close to this. Remember, u can't be the denominator. It could be part of the denominator. Well, I have all that, except I have negative 2 times it. Okay? So we're going to rewrite this as, and remember, this is undefined at 0. So this is an issue, and that's where we're going to have to actually do our limit. Okay, so this really becomes e to the u, but it's negative 2 du. And now I'm going to go change my limit. So if I plug in 0, I still get 0. If I plug in 4, I get negative 2. But remember, those are kind of in the opposite order. So I'm going to rewrite this and make it a little bit nicer. And I'm going to write it from negative 2 to 0, and I just flip the sign on that because of our rules of integration. All right. So now we still have to do the limit as b approaches 0. So I get the limit as b goes to 0 of the integral from negative 2 to b of 2e to the u du. But I know we all know the antiderivative of e of the u is itself. So I get the limit as b approaches 0. And by the way, this is from the left. Because if I think of here's negative 2, here is 0. I'm approaching it from the left side. And what do I get is that's e to the u from negative 2 to b, which is the limit as b approaches 0 from the left of e to the b. I'm sorry, I dropped my 2 here. Minus 2e to the negative 2. Well, as b approaches 0, this is 1. So what do I get? I get 2 minus 2e to the negative second, or I could just write it as 2 minus 2 over e squared. So it does converge. It is a finite area. Okay? All right, so the last one I want to do is a little bit uglier and probably a little bit more advanced than what you're going to see on the upcoming chapter test. You could see it on the MP exam, so I at least wanted to cover it. All right, so this is one we actually have to do by parts. But the problem here is, remember, it's infinity is where we're going to have to do a limit of it. Limit as b approaches infinity. But with parts, typically we pick u as x and dv as what's left over. But it's not that way. That kind of holds true as long as it's not a natural log of an arc. Okay? So we're actually going to let u is equal to the natural log of x, and dv is equal to x dx. So knowing that, du is 1 over x dx, and v is equal to 1/2 x squared. Okay, so I'm going to do uv minus v du. So this really equals u times v is 1/2 x squared natural log of x minus the integral of, and I'm going to throw our limits on at the end, and I do the product of those two, I get 1/2 x dx. Okay? So if I integrate that, I get 1/2 x, that should have been squared, x squared natural log of x minus 1/4 x squared. I'm going to look at that from 1 to b. So I get the limit as b approaches infinity of 1/2 b squared natural log of b minus 1/2 natural log of 1. And then I get minus 1/4 b squared minus 1/4. Which as b goes to infinity, this is going to get infinitely large. Okay? So it doesn't matter. And this one you get infinitely large but going to the negative. But since they really what we can say is it diverges, because these do not necessarily cancel out. This one is actually growing a little bit faster because you're multiplying it times the natural log of b. So it does diverge. So that area is not finite. It diverges. Okay? This one's a little bit more than I think you can expect on the upcoming chapter test, but I at least wanted to show you the example of how to do it because you got to do it by integration of parts. Okay? Thank you. Hope this relieves some fears here.